In this video, we are going to remind ourselves about functions. We are going to talk about functions throughout the whole semester, so we want to make sure we remind ourselves about some notation and some terminology. If we recall the definition of the function, I won't write it on the board, but it's a rule that assigns to each element in a set called the domain exactly one element in a set called the range. So we can think of this as your domain, and we have range, and we have F makes this assignment. It assigns this element here to that element there. Now, functions these sets can be lots of things. These can be people, and they can be assigned to a social security number or a student ID number. And each school is going to have a different function for that ID number. Schools have different types of ID numbers and various things like that. Or they can be, what we're going to deal with is these are numbers, mostly real numbers, and F is going to be some algebraic or computational function. We can also have a set of data. So we can have a set of data where we have patients, and each patient is assigned, we have in our data their heart rate at their last physical. And so we can have lots of different types of functions. And again, the key is that this function only goes to one. It does not go to two different numbers. When you press a button on your calculator, you don't get two numbers as the answer. You only get one number as the answer. And so that's the key about functions. And function notation, a lot of times we are going to use y as a function of x. And sometimes we're going to change it up. A lot of times our input variable is going to be q for quantity of items that we are making and selling. And this letter might be different also, but a lot of times in our examples we're going to, that's what we're most familiar is y is a function of x. Once you know what your x value is, you plug it into your rule or look on the data, your chart, look on the graph, and that tells you what the y value is. And the function notation is always name of function, and then we have the input. So we're going to look at our first example, f of x equals x squared. And in part A, we're asked, what is f of 5? So f of 5 tells us when we plug in 5 for x, that means we're looking at f squared, otherwise known as 25. For part B, we are given g of t. So just using a different input now. T is a very common input variable. A lot of times t stands for time. We're given the square root of t squared plus 1. And we're first asked what g of 0 is. Now, some people, the more practice you have, the more recent your last math class was, you might not need to write down everything, and you can do some of these steps in your head. But what this is saying is when I plug in 0 for t, we're looking at the square root of 0 squared plus 1. That's a plus. So you get square root of 1, which is otherwise known as 1. Right? Again, some people are able to go either right to here or even right to here, the more practice you have. Be careful with some of our orders of operations. When I plug in -3, that means negative 3 is t. So it's negative 3 quantity squared, and then we add 1, and then we take the square root. And so that would be, I'm not going to write this down, 9 plus 10 underneath our square root of 10. This is our exact value, so we can just leave it at that. Some of our other problems, we might have something a little more abstract. We might ask, given this f of x, we might be asked, what is f of t plus 1? And let's go back to our function notation. What this means is whatever is in here, I'm going to take that and square it. So if I have f of smiley face, I have smiley face squared. So here I have t plus 1 is my input, so it's t plus 1 quantity squared. And I could expand that out, FOIL it out if I wanted to get 2t squared plus 1. Either of those would be fine. In fact, a lot of times this might be easier to deal with. Part D, we're looking at, again, G. This rule is saying that whatever I have, let me rewrite this, G of whatever's in the parentheses, I take the square root of whatever's in the parentheses squared, add 1 like that. So for D, we're given G of x plus h. We would have x plus h inside our parentheses, quantity squared, plus 1. And again, we might simplify that, but right now that's what we would do.